I'd like to show you one of the newer features in ERA. It's been in there for a little while, but it goes easily missed if you're not aware of it. In the string builder, if you click on a joint of drill pipe and you pull up the dimensional characteristics and performance properties, what you may have noticed in recent versions is that we now have some inputs for slip geometry. That is the length of the slips, the angle of the bowl of the slips, and then this value mu, or coefficient of friction, which is the coefficient of friction between the bowl and the slips themselves. And we've got default settings here that represent the typical values, and then also in the drop-down list, some of the more common optional values. So short slips is default, long slips is an option, and there's a couple other optional bowl angles. The most conservative calculation, if we're concerned about slip crush, is to assume that this coefficient of friction is a low value. And we've got some other slightly higher values. We recommend using a conservative value unless you know otherwise. But what we do with these inputs, as well as the drill pipe dimensional and yield strength information, particularly the slip area ID and the minimum yield strength, is we can calculate the limit at which the tube of the pipe will crush due to the lateral force imposed when we set the pipe in the slips. And you'll notice on your tension plots here in the background, we've got a green shaded area, which represents the slip crush limit for this pipe. Now, depending on what the area of the ID in the slip area is, or on the geometrical configuration of the slips, that green shaded limitation will change. So if I had longer slips, for example, you'll notice that my slip crush limit will change from 390,000 pounds to about 430, 440,000 pounds. Likewise, with a steeper bowl angle, slip crush improves. And if I were to change the yield strength of the material, if I was to use, like, say, 150,000 psi yield strength material, that would also increase the slip crush limit. So we take that into account now, and we just want to be careful whenever we're looking at our pickup loads that we don't let the tension exceed the slip crush limit. Otherwise, we could fail the pipe in the slip area due to that lateral force. The other thing that could easily go unnoticed is this button in the lower right-hand corner called TJ Performance, which stands for Tool Joint Performance. And that option is available as long as the connection that we've selected is one of the connections in this drop-down list. And the drop-down list gives us all of the API drill pipe and drill collar and heavyweight drill pipe connections. So if you select one from the list, or if one from the list is automatically by default picked from the library, for example, 4.5 IF, or the modern terminology NC50. If I click on tool joint performance, it will bring up the performance envelope not only for the tool joint, but for the tube itself. So here what we're looking at is the combination of tension on the tool joint and the torque applied to the tool joint. And there's various limitations here. The diagonal line that originates at 0 and extends upward represents the combined limit that would result in the shoulder separating. So if I had, let's say, for example, 800,000 pounds of tension, in order to keep this tool joint shoulder from separating and causing a washout, I would need to apply at least 18,000 foot-pounds of makeup torque. So increasing makeup torque gives me increased tensile capacity before shoulder separation occurs. Now, this horizontal line represents the tensile capacity of the pin. If I apply any tension in excess of 1.25 million pounds, I would yield the pin if I'm just looking at the tensile load. Now, unfortunately, when we apply torque to the pipe, once I reach full makeup, increasing torque results in the pin experiencing stress both from torque and from tension, and it's actually this diagonal line on the right-hand side of our triangle that represents the combined limit of the pin under tension and torque. So if we follow this line all the way down to the x-axis, the way you interpret this is the tool joint, the pin's maximum torsional capacity is about 52,000 foot-pounds. So I would yield the pin even with no tension applied at 52,000 foot-pounds. Now you'll notice that there is a vertical red line which represents the makeup torque that I'm applying. And by default, we'll assume that we're making up the pipe to the API recommended value. And API recommended makeup torque will be the lesser of either 60% of pin yield or the lesser of either the pinnacle of my shoulder separation or my pin yield line. So that doesn't mean that I can't make up the pipe to higher makeup value. So if I was to put in 35,000 foot-pounds of a makeup torque, here's where my makeup torque line resides, and the way I use this is it tells me that I shouldn't apply more than 840,000 pounds of tension, otherwise I would fail the connection in under combined load. Now put that in perspective with the tube. This blue line that arcs downward represents the combined load limit of the tube, which is the real limit here of the pipe. If I was to have 35,000 foot-pounds of torque on the pipe and I had 550,000 pounds of tension, I'd yield the tube. Now, to retain conservatism, this dotted line represents that tube yield, but with a safety factor applied. And in your settings dialog, we've got a design factor, a VME design factor of 1.2, which is what is driving that blue dotted line. If I was to reduce the VME design factor, then this curve would move up or down depending on my change. And then the last thing to show is my horizontal green line, which is that slip crush limit. If I was to change properties about the tube or the slips, then that horizontal line would move up or down. I said the last thing. The only other thing that we need to point out is this vertical gray line on the right-hand side, which represents the box yield limit, the yield of the box. And in this case, this is a pin weak connection. The pin has less torsional capacity than the box. Now, if I was to change the dimensions of the pipe, it could result in a box weak connection. So let's just change the box OD here to say 6.5 inches or maybe 6.25 inches. You'll notice that we recompute the performance properties of this tool joint based on the OD, ID, and of course the minimum yield strength of the pipe. So that can be a quite useful feature if you're operating with something other than standard API dimensions. If your drilling contractor has ordered different drill pipe dimensions, then that's going to change the performance envelope. Maybe you order drill pipe with a higher material yield strength. So let's say I've got 135 KSI tool joint material. Well, that changes my torsional and tensile capacity of my assembly. So this could be a quite useful feature if you're trying to make the most of your API connections. As I said, it can go easily ignored or missed, and it is accessible here in the lower left-hand corner.